Well, good morning, everyone. Welcome to our session, building a data-driven interior configurator using Lumen and Nanite. My name is Josh Triplett, part of Gulfstream Aerospace. I've been there for a little over 16 years. I work on the advanced tech team where we, among other things, work in the Unreal Engine in the simulation areas, as well as engineering and in industrial design visualization. We do sales and design tools, which is kind of what we're going to be talking about today with our cabin creator configurator. So just to give you a brief overview of the agenda, we're going to do introductions, which we're doing now, and then I'll give it up to Brian to talk through a little bit about Gulfstream and how we use Unreal, a little bit of our history as well. We'll do a live demo of our cabin creator tool, which is what we're talking about today. And then he'll go into kind of the data conversion process that we use to bring CATIA data into Unreal. And then he's going to give it back to me to talk a little bit about the backend for our newest version 3.0 for the cabin creator tool. So what we're trying to do kind of with this session is a little bit of a shotgun effect. So we did a lot of different things to kind of bring this data-driven configurator to life in Unreal. We're going to go over some of the techniques that we used. We're going to go through some of our methodologies and thought processes behind those so that hopefully you can maybe take a few nuggets away and use them in your own projects and app development. And with that, I'll give it up to Brian.
Good morning, everyone. I'm Brian Toller with Gulfstream Customer Support. I work in systems training. I also work our advanced tech and extended realities team. I'm going to go into a little bit of the history of Gulfstream. This is our Grumman. In 1958, Grumman Aerospace gave flight to the G1. It was the first step into business aviation for Grumman and what became Gulfstream Aerospace today. There's also some fun facts. Obviously, Disney had a G1 and managed to scout out the area using his G1 for a part of that time. In 67 years, we produced over 17 aircraft. Our current fleet consists of 1 mid-cabin and 5 large cabins. In 2000, we began to develop the G650. It was our first aircraft entirely developed and certified using CAD 3D. It was also the first step towards a digital thread. This past March, we certified our G700, our largest aircraft with 5 living areas. It can seat 19 passengers, sleep 13, and has an enormous selection of interiors available. This is a photo, and this is Unreal. As you can see, we have a lot of different layout options. Each product varies and is unique to itself. So how do we make the process easier? In 2021, we started looking at building a new app that would support our sales design team. It would allow our customers to block out the aircraft and visualize material options quicker. We introduced Cabin Creator in 2022, built using Unreal Engine 4.27. Cabin Creator 2 came with some caveats, requiring hours of baking, limited layouts, usually 3 to 4 layouts per product, and limited material styles. The 3D pipeline was a much longer process too, and it could take weeks to prepare assets. Then in 2024, we migrated to Unreal Engine 5, and in a year, we were able to completely rebuild Cabin Creator from the ground up, deployed with 8 aircraft and with an unlimited amount of layouts and material combinations. Like most projects, it takes a village. The core team of Cabin Creator was 2 to 4 people at any time, and we worked with our Viz team to develop and deliver the final materials. So I'm going to jump into a demo so you guys can actually see it. I will say this is still in work, so there might be some bugs. And actually, you're seeing it before some of the customers are seeing it. So this is our G600 aircraft. We're starting in the galley, and I can move through the cabin. This is all in real time, obviously. We're using Nanite and Lumen. One of the nice features is we have a layout function, so we can come in and also change the different styles and settings on the fly. I can go into our interior section. We can go into the veneers. We can quickly change different veneer settings. I can go into the flooring We can change out our flooring, our carpet. And then we can even break out, let me go back to the seats, go into our materials, and then I'm going to break this out into a monument section. So if we want to do our seats, we have a whole section dedicated to just the seats. So we can go in and modify the colors, go into our inserts, and let's see. And quickly see our seats. So now I'm going to jump into our current pipeline. With the original Cabin Creator, it would take weeks to prepare models, UV, bring into Unreal Engine and bake scenes. Granted, we haven't defined a one-button solution, but we have managed to get the process down from weeks to hours, and in some cases, minutes. Sometimes it takes even longer to actually find the assemblies than it does to actually process them. We tessellate and convert the NURBS data. This leaves us with roughly so this assembly leaves us with roughly 1.3 million for the assembly. Just for reference, the aircraft has 907 unique parts inside of it, with a 38,000 total parts. So estimated just the cabin is 702 million triangles. We apply a baseline texture to identify improper UV directions and remove additional model data. We also keep a fair amount of the internal geometry in the event that we want to open up doors, add lighting, or do other animations to it. This also leaves us with roughly, after we're done with this process, about 147,000 triangles. We could probably remove more, but it's not necessary for our application. We resize the UV across the assembly and export. We would bring the model into a digital content creator, but now with the UV editor inside of Unreal, we really can eliminate that step. The final assembly installed running in Cabin Creator is right here, and kind of like what I've shown you previously. The total time from CAD to in-engine is less than an hour. So it's been an amazing change for us with Nanite, Lumen, and all these features that Unreal has today. And with that, I'll pass it back to Josh.
All right, thanks, Brian. We've hit it at the same time there.
So let's talk a little bit about the new backend. So Cabin Creator 3.0, we decided to revamp the backend a little bit. And so I'm going to kind of go through some of the processes that we use to create this data-driven backend. I have a few kind of simple examples as well that hopefully you can take back and maybe use for your projects. And to talk about Cabin Creator 3.0, I'm going to first talk about Cabin Creator 2.0 and why we kind of decided to change some things. So first off, there was basically one blueprint. This thing was enormous. It was a widget that contained all the widgets and all the blueprint. And I mean, you can see there, it was not easy to navigate around in. So what does that mean? It's really, really hard to make changes in the blueprint. Even finding things, even though it's fairly labeled, not easy to do. It was actually getting to the point where we were seeing like performance issues while navigating in the blueprint. So we were getting like 1 to 2 frames per second frame rate just navigating in the blueprint. So it was almost impossible at that point to even continue. So there was not really functions. There's a caveat. There was a few functions, but most of it was just this button, the next button, the next button, changing some variables, that kind of thing. So. Lots of duplicated functionality. If you had to change something, you had to change it on every single one of the things instead of in just a function. So here's our user interface for 2.0. Again, it was pretty much one widget, virtually impossible to find anything in it. We didn't necessarily have super standardized naming conventions even, so doing searches in that blueprint didn't work so well all the time. Sometimes you could find something, sometimes you wouldn't. Everything was hard-coded. There was no instantiation or anything like that. It was not responsive, so it would work on certain screens, not on others, which for our purposes wasn't necessarily that big of a deal because we control a lot of the hardware that it goes on, but still, we wanted to be able to build it responsive. And as you can imagine, one small change cascades. So if you have to remove a button, you have to then shift all the buttons over
I mean, it's a whole process. And here's the worst part. Every single aircraft had its own application. There were 8 aircraft. If we made one change, we had to do it 8 times. So what was our solution? We were going to build it from the ground up. And this, I put this in here because this is an image of what I imagine my boss looked like when I told him we were going to completely redo this application. I don't think he was happy with that, but all right, the dream. So Cabin Creator 3.0, what were we wanting from this? First off, we wanted it to be data-driven as per this talk here. What does that mean? We wanted data files to drive the 3D functions in the UI. So rather than having everything be hard-coded, we wanted everything to come from these data files. So one of the other things we wanted from this is to be able to manipulate the data outside of the application. So rather than having to repackage every time we made a minor change, we want to be able to manipulate some of that without repackaging, as that says. And then we also wanted to make it more modular. So rather than having one blueprint, we wanted to separate everything into kind of its own constituent parts. All right, so scalable UI. We also wanted this to be scalable, so we wanted to be able to add or remove buttons without that cascading down and affecting everything else. We did not want this to be hard-coded. We wanted to use as much data-driven workflow as possible for it. We wanted it to be responsive, so we wanted it to work on a lot of the different screens. We do have everything from a laptop up to a power wall, so we wanted it to work on all these different kinds of devices. And then we wanted to use Unreal 5. So moving from Unreal 4 to Unreal 5 gave us the ability to utilize Lumen and Nanite, which is going to greatly increase our abilities to not obviously have to light map bake. With those applications, we actually, because we had to separate them out, each application was around 20 gigabytes each. So with all the textures we're putting in there, all the data, everything, you're talking about 8 times 20 gigabytes. So we wanted to do it all in one application instead, and we wanted that one application to be less than 20 gigabytes. And just to let you know, we have all of our aircraft in this application, and it's actually under 10 gigabytes now. So it's quite an impressive improvement. And then also we wanted to be able to add our layout and styling. As Brian mentioned, we're pretty limited with just being able to do floor plans and basic seat styles, but we wanted to put all of our layout and styling in there, which there's a lot of layout and styling, and then eventually to be able to add the exterior as well. So step one, we decided because this was going to be such a massive project, we wanted to really structure it up front. We built a wireframe diagram. This is our wireframe diagram. You're not meant to read all of this, obviously. It's way too tiny. But it's more just to show you generally kind of what it looks like. And so why do we build a wireframe? Number one, because we wanted to be able to structure this whole project before building it. And to understand the workload, so if you go into a project and you don't develop a wireframe first, a lot of times you have absolutely no idea how much work you're going to need to do. You don't know how much time to put into it. You can also understand the cost a little bit better, so depending on if you're bringing in third-party developers or things like that, it'll help you understand how much your cost may be up front. We also utilized this so that we could figure out which external teams within Gulfstream we were going to need. So for instance, we store some of these projects on servers, so we knew we needed to talk to infrastructure. Security is a big deal with Gulfstream, so we knew we would probably need to talk to security and bring those teams in as well. And then obviously no spaghetti code whatsoever if you do this. So data-driven, why did we want this to be data-driven? Just to kind of re-say all this, we wanted to be able to change the data without repackaging. We wanted it to be fairly easy to make minor changes. This was a big one. We wanted to be able to hook data into other apps. So if everything's stored internally in Unreal, it's a lot harder to kind of grab that data and use it within other applications. So we're kind of trying to develop a whole architecture here where we are able to use that data and the save files and things like that to hook into other applications eventually as well. Wanted the UI to be scalable and the scene also to be responsive and scalable. So we looked at a couple of different data types when we were building this application. So the first one was the CSV files. It was a pretty easy beginning one just to start with and think through. There's several pros to CSV files. Obviously, it's very widely supported. You can manipulate it in Excel, so it brings it right into data tables in
Excel. It's very human readable. It's literally just strings separated by commas, so you can read it very easily. But there's also several cons to CSV files. They're one-dimensional, so it's hard to get hierarchy or objects within objects within objects. And then you're limited to only numbers and strings for a variable. We also looked at structs within Unreal itself, so there's some obvious pros with that. You can use any variable type that Unreal has. That's a nice bonus. Also human readable, you can just go into the struct and see what you have in there. However, the cons are, again, that it's one-dimensional. While you could have structs within structs, that's not always a very good idea. You can break your program pretty easily if you make changes. And you can only update and change this or really read it very easily within Unreal. And then finally, JSON, which is what we went with. So why do we choose JSON? Here's some of the pros here. It's multidimensional, so because of the use of objects, you can have objects within objects within objects. You can have lots of layers. It's widely supported, so just about everybody supports JSON. Human readable, so even though there's a few tags for coding and stuff like that, you can still go into the file and read it very easily. It's very simple, very easy to use. Here's a big one for us. As I mentioned, security is a big deal at Gulfstream. Bringing in new, even just data types sometimes can be difficult. So we are using it in a lot of applications at Gulfstream, so there's no worries about that. And it's always, it's already tied into other Gulfstream systems as well. Again, there's still cons though with JSONs. It can be difficult to manage larger JSON files because of the extra coding. That could probably be said of any data type, however. And then you are still limited with variable types to strings, bools, and numbers. So we decided to kind of break up our data files into two different types. So we've got manifests, and then we've got schemes. And I'll kind of tell you a little bit about what the difference is. So manifests are not going to change at runtime. There's a limited number, so we sort of pre-program these manifests ahead of time, and anytime we make changes, then we'll push a new manifest file. This is what's going to drive kind of what shows up in general in the app, so any of the menu options, buttons, things like that, and also what shows up in the actual scene itself. Schemes, on the other hand, do change at runtime. There theoretically could be an infinite number of them because the customers actually can make or delete different scheme files. They drive the currently selected options, and basically it's a save file. This is kind of a real high-level structure of how we're utilizing that in our system. So we're using the VA REST plugin, which is, I believe, free on the Fab Store. It's actually a REST API, so it does HTTP interactions, but it also has a pretty robust JSON management system. So we're just mostly utilizing it for that. For the time being. Down on the left here, you can see that we load the JSON manifest in. There's kind of a general, basic idea of what that might look like. We use that to then spawn the UI, and then we use it to spawn the scene itself. And then on the right there, we will load the JSON scheme, so there's kind of a general default save file for each individual option that we'll load. And again, looks pretty similar to the other one. From there, we will make changes to the scene, or the customer will make changes to the scene, and then it will save back out that JSON file. So we utilize the asset registry quite a bit in this program, in this application. So I'm going to go into this a little bit, and we'll have a quick example of what you could maybe use that for. The asset registry you can utilize to basically pull an asset based on the name and location. So anything that's in your content browser, even if it's not loaded in the scene, you can just pull that right out. You don't have to use variables or anything like that for it. So we define the name of the asset within the JSON file. So that's how we use the data file itself to drive what we pull and bring into the app. And it basically just locates the files. One thing to mention on this is that project structure is really important. So because you're going to be stringing together locations of assets, you want to have a good structure for where things are located in folders. You don't want to just have everything kind of haphazardly throughout your project. That's going to make it a lot more difficult to do this kind of data-driven workflow. And on that sense, we use a project locations manifest. So we actually have a manifest we bring in that strings together locations for folders. And the reason we do that is because if we determine at some point that we want to change where the folder is, we don't then have to change every single asset in the application. We can just change that kind of general folder structure, and it'll update automatically. Now, something else to mention is one of the things that we wanted to do was we wanted to be able to pull in UAsset files into the project post package. So you can actually, depending on how you set up your project, you can bring on UAsset projects and then use the asset registry to pull those assets that weren't cooked initially. But you have to, for the asset registry, you then have to actually update that asset registry on start. That's really expensive, so you kind of have to build a structure around how that's going to work so you're not just searching every single folder. We haven't had the time to do that yet, but that's kind of one of the things we'd like to do. All right, so here's just a really basic example of how you might use this. So up here, you've got just a really, really simple JSON file. It's got a single string material called m_test_01. And then we've got a function here where we're going through two sets of sequences. Here's where we're using the VA REST subsystem. From there, we can just load a JSON from file, which we're feeding this in, this materials.json file, which is this here. You can make that relative to the content directory, which it's just right in the content directory in this sense. And then from there, we're going to get a string field called material, which is this string field here. And here's how we're actually going to build the location so that the asset registry understands it. So /game is actually your base content directory. So when you're running in game, that's what it expects rather than content. And then assets is an additional folder within that content directory. Now from there, to actually name the asset itself, we have to use the name, which here we're pulling this string. So we have m_test01. And then it expects a dot, and then that name again. So just porting in the name itself isn't enough. It needs the name dot the name again. So we're just storing that in a local variable here. And then next, we're getting our asset registry, and we're porting in that local variable we just created. We're getting the asset by the object path, which returns this data struct for the asset itself. There's a function within Unreal to get the asset itself. So this is going to give us, I believe, an object. It's going to return an object, and then we can cast to that object to whatever it is. So in this case, it's a material, so we're casting to that material and outputting it to use it for whatever we want. All right, so modular system. Again, we wanted to create a system that has a little bit more bite-sized chunks. We wanted to be able to separate the functionality, and we wanted kind of one group of related functions for each module rather than one blueprint to rule them all. So here's kind of how we went about structuring that. So we have a module controller, which is just a basic actor blueprint. The reason we wanted to go this route is because we wanted to just pull that actor just into any scene and it just work. So this allows us to do that. From there, we have a few different elements. We have a data actor component that is attached to that module controller, and that's basically going to control everything that relates to the data itself. It loads and saves the data, so from the manifest files and the scheme files, and it manipulates that data, things like that. From there, we have a 3D and manifest function, which again is an actor component attached to the module controller. This is basically going to manipulate anything within the 3D scene itself. It's going to change the manifest when a manifest needs to change, and it's going to change the scheme when it needs to change. And then we have a widget functions actor component, again attached to the module controller, which controls all the UI, the buttons, the menus, things like that. So this was just a way for us to kind of break it up and keep everything kind of separated from each other so that it would be a little bit easier to go in and manipulate as needed. Talk a little bit about our 3D scene. So we use world partition. I was a little hesitant to move over to it, but once I did, I was glad I did. It's really nice, actually. We don't necessarily use it to stream levels in the same way that maybe a game might do it, but we are able to set it up so that we have one level per aircraft, and that one level controls basically everything within the aircraft. We use data layers then to swap between floor plans and things like that. Allows us to manage everything within one level, and one of the nice benefits of this is we can have obviously one object that's on multiple data layers. This is just kind of a high-level overview of what our level hierarchy looks like. You can see on the left there we have kind of our main level. Then that's broken up into data layers, which are the layouts or the floor plans themselves. Then from there we break it out into a zone, which is an actor blueprint. And then in each zone are these child actor blueprints that we call monuments. And these would be like the seat or the table or the ledge. And then from there, we can have styling that we can add to certain monuments. So like the seat has stitching options, it has different options for the cushion, things like that. And then under that, we can change the materials as well. So just to kind of give you a breakout of what that might look like here. So this is our 600, and we have 4 major floor plans for this. We have like aft galley versions, we have 3.5 cabin options or 4 cabin options, and this is how we kind of can use the data layers to actually go through those floor plans. Under that, we have a zone. So if I actually go back here, a zone would be like this section right here. So you can see there's several zones along this cabin. Like in this case, there's 3 different zones. And within the zone, all a zone is basically just a scene component that we've added a few variables to its custom scene component. You can see the variables over on the side, and this is what the JSON files will store this information, and then the functionality in the back end will look for this to make it visible or invisible. And then each of these then are just child blueprints under the zone itself, and those are the different monuments that go with that zone. So here's a monument. This just inherits from a actor blueprint monument type, and it has these 2 actor components on it that this one will change the materials for the object. It'll automatically look for whatever materials it needs to and then change those based on button options. And then we have a style as well that controls the style. And then for the style itself, so this would be under like the seat monument. Again, we have just a scene component that we've customized with a few variables over here. The JSON files look for these variables and then turn these particular options on and off. All right, so let's talk a little about our user interface. Again, we wanted this to be responsive, we wanted it to be scalable, and we wanted it to be data-driven. So I'm going to give you kind of an example of how we might spawn from a JSON file and create a series of buttons on the bottom. So here you can see we have kind of our main widget. We're just adding this to the viewport on start. It has a overlay here just to kind of contain everything, and then a scroll box down here at the bottom that's empty. And here we have a button widget. So this is a separate widget for our button. It's a little more complex, but all you really need to know about it is it has a header text. It has a background image, and then it has just kind of an invisible button over that we can use to like add tooltips and things like that. So this would be, again, it's a little more complex here, but this is how we might spawn a button based on a JSON file. So we have our JSON file up here. It's a little more complex than the last one. We have this object array called buttons, and then under that, each one of those objects has a name, a thumbnail, and a tooltip. And they're all slightly different from each other. And I'll go through what each of these does now. So first, we're going to load the JSON from the file. We're doing this just like we did before. We're using our VA REST subsystem and then loading this JSON from the content directory called UI.json. From there, we're just going to get that object array field called buttons, and we're going to store that as a temporary variable in this function. Next, we're going to iterate through that JSON, those JSON objects. And for each one of those, we're going to create a widget of that button type. We're going to add that to another temporary array just so that we can manipulate that later. And then we're going to add that as a child to our scroll box button. So that's going to actually add this widget that we've created, and however many of the JSON objects we have, it's going to add that many to that scroll box. Next, we're iterating through those buttons. You don't have to do it this way, by the way. I just wanted to chunk it up into each section so you'd be able to see kind of individually what each one is doing. You can kind of have them go one after the other. But we're iterating through our widget buttons that we created. We're going to get the JSON button object associated to that. We're going to get that name, which is this here. So the first one is button 1, then button 2, then button 3. And then we're going to get the header text and just set the text to whatever that string is. Next, we have our, this is using our asset registry like we'd done earlier to actually get the thumbnail that's going to go in the background. So again, we're iterating through the buttons and then getting the JSON button associated with that. We're going to get the thumbnail, which is right here. And we're going to figure out which folder we're in and get that asset from the asset registry, from that object path. In this case, we're going to cast it to a texture 2D, and then we're going to set this thumbnail image from that widget button to whatever that texture 2D is. And then finally, we're going to set the tooltip text for the button. Again, it's the same basic process, but in this case, we're going to get the main button and set the tooltip text. So, this is a simple example, but this is basically how we created all the UI. It gets a little more complex for some of it, but this is basically how it worked. And then this is the result, so you can see that it's spawned to these 3 buttons down here. The text is different for each one. This is the background image. And then if I hovered over them, it's just an image, but if I hovered over them, you would get the tooltip text as well. All right, from there, let's talk a little bit about performance. So obviously, when dealing with Lumen and Nanite, it's done some amazing things, allowed us to do things we've never done before, but performance is certainly an issue that we need to tackle. One of the big things is you got to deal with performance and quality, and you've kind of got to figure out where that nice middle line is, between those. You're always going to be either GPU bound or CPU bound. In our case, we found ourselves to be both in different situations, so we had to do some performance enhancing on both ends of that. Here's just some basic console commands if you're not aware of them. These will help you to very generally see what the GPU and the CPU are doing, what the render thread is doing. So some of the issues we found on the GPU, Lumen is pretty expensive. It was about 1/3 of our rendered frame. Now, depending on what you're using this for, when you go to, for instance, the outside of the aircraft, it tends to not be quite as expensive as the inside of the aircraft. When you've got a long, narrow tube, that actually is, we've always had difficulty rendering that. It's always much more expensive than, certain other things you could render. You deal with a lot of Lumen artifacts, so a lot of it is, again, finding that balance between performance and quality. So you've got to, in our case, we've got to up the Lumen sampling and things like that to get the quality that we're looking for. But we've got to be very careful with our frames per second. And one of the things we had to do was limit our lights. So because we have a long, narrow tube and there's a lot of strip lighting in it, we had to find ways that we could kind of combine that lighting together, but still kind of get that ability to swap out different zones and things like that. But we tried to first add every single little light, and Lumen wasn't having it. We have not tried yet using megalights in it. That may solve a lot of that issue, but that'll probably be next on the agenda. So now, as far as the CPU is concerned, VA-REST actually we found iterating through really large amounts of data and using VA-REST to pull the JSON data, one thing after the next, sometimes had a performance hit. So we would have to sometimes store the variable locally within a function and then iterate through those variables instead of the actual VA-REST JSON objects. And then loading levels, Nanite is obviously heavier than the way things used to be. So when we load the levels, we had to do some performance things. Because we're loading so many different variations of the interior, every one of those variations would load at the same time. So we had to change some things so where it would only load whenever you were using that particular element. And then obviously textures, because we have a huge amount of materials. Just to give you an idea, there's actually over 70,000 materials that you can put in our cabin. We have nowhere near that in this application, by the way. But we do have quite a few in this application, so loading all those textures can be expensive. And we used Unreal Insights Trace a lot in this just to trace down particular performance problems. And I'm going to kind of go into what that looks like, how you can utilize it for your own projects. So it's really easy to use. Down here at the bottom of your screen, you have a trace drop down, and then there's this little button right here as well. So if you click on the drop down, you can start a trace by clicking this, or you can just click this little button here. And basically what that does is it just, wherever you click that start trace, it starts tracing. It starts recording everything that's going on within the application. And then you can stop that once you've done whatever it was that you wanted to test. And then you'll get this huge amount of information like this. So please don't try to read all of this. That's a lot of info. You can see you get everything that essentially happened. So like this is a button click. So this is when I clicked a button. This is what happened. And you can see, this particular function happened, and then from that function this happened, from that this happened, from that this happened. And you can really get super granular in exactly what's happening. So like for instance, in this case, this function, this whole button click took a little less than half a second, which is, not great. But you can see this function right here is like more than 3/4 of that. So we can kind of begin to narrow in and see, well, there's a lot of iterating going on right here. So what is that? Is there a way I could simplify that? Is there a way I could make it a little more performant? And again, we would have never seen that the VA REST was as expensive as it was without using Insights Trace, because that showed us, oh, that's actually taking a while for those to iterate through. So here's some kind of basic lessons learned going through this process. Very hypocritical for putting this one on here. Please make better documentation and notes than I did. I have to now, after the fact, do this. But it's obviously, for anyone else who's going through your program, it can get really big really fast, and it's hard for people to find things, as I'm sure Brian can tell you. Not everything has to go in the JSON file. So I wanted to try to, I kind of had a knee-jerk reaction to say, okay, everything was hard-coded, now everything should be data-driven. But that's not necessarily correct. So Unreal makes these little sidecar files that you can create called data user asset files. You could put some of those variables within those files. And those you can attach then to basically any type of view asset that's in your project. So you could, for instance, have materials that are tied directly to thumbnails that are in the project, things like that. So, if I went back and did it again, I might try to use some of those techniques just so the JSON files themselves didn't get quite so bloated. Give everything a unique identifier. So some of our manifests started off not having a unique identifier. And by this, it's like, for instance, if you have 50 materials, each material has its own unique name. And the reason that that's important is because if you ever want to try to find that material in the application, if you don't put a unique name, then you're going to have to find some other way to figure out which one you're looking for. So just adding a unique identifier is an easy, quick way to be able to find those things in the JSON files. Some hard-coded is okay. Again, we tried to kind of go completely the opposite direction. We tried to put some functionality in the data-driven files that we probably didn't need to do. If you have specific functions that aren't going to change much, then it's okay to hard-code those things. Lock down the engine version. So working with our Viz team, we started in Unreal 5.3, and our Viz team started in 5.5. So when they gave us our materials, we had to upgrade to 5.5. There was no way around that. So lock down that across your different teams. Make sure you're all working on the different or on the same version. It's very important. We also saw a lot of CATIA to Nanite artifacts. We're still kind of trying to track down exactly what causes that, but you may see some of those issues as well. You can kind of fix some of those either by turning Nanite off for that particular object, which I wouldn't do a lot of because that can then affect performance a lot. But you can in certain situations, or you could go to an external DCC and try to fix some of those issues. And with that, I think we are done. So thank you very much. And I think we have a few minutes here for some Q&A. If anybody has any questions, you can come up to the mic right here.
Oh, hello, everyone. Hello. Thank you for joining my sessions. I hope you are having a great day so far in Unreal Fest. It's finally last day, right? I'm Jisuban. I am a software engineer at Hyundai AutoEver. Today, I'm excited to introduce the world's first vehicle navigation system developed using Unreal Engine. I'd like to share our development journey as we work to render our maps in Unreal Engine. I will work through how we achieve this and highlight the key Unreal features that made it possible. And I want to take a moment to thank Epic Games for giving us this opportunity to present our project, and especially the Epic Games Korea team for all their support along the way. And I'd like to tell you a little bit about myself. I worked as a graphics engineer at Hyundai AutoEver, which is part of Hyundai Motors Group. And I've been working in the graphics engine development team for the past 4 years. My team has been building our own in-house rendering engine for vehicle map visualization. And I've been focusing on integrating with Unreal Engine for real-time application. Before joining Hyundai, I worked on creating 3D CAD program at another company. And also I researched on physics-based simulation in the graphics laboratory at Korea University. I've been building my career as graphics engineer for about 8 years now. Before I dive into the details of our navigation system, I'd like to briefly introduce my company for those who might be unfamiliar with it. Hyundai AutoEver is the software specialist of Hyundai Motors Group. So we provide leading service and technologies in the field of mobility. We developed vehicle software for future vehicle, as well as digital transformation such as smart factories and digital twin platform, and core technology about cloud, big data, and security. Have you ever driven a Hyundai or Kia vehicle? Have you ever? Thank you, great, thank you. If you ever driven a Hyundai or Kia vehicle, you have probably experienced our in-car navigation systems. So Hyundai AutoEver is a pioneer in the in-vehicle infotainment system, driving the future of mobility. So we have accumulated advanced technologies and know-how in the GIS field. So we make sophisticated high-definition maps for navigation systems and autonomous driving. In the image you see on the screen shows our navigation system that was exhibited at CES this year. We collaborate with Hyundai Mobis and Mapbox to develop this navigation system, which features AI-driven 3D navigations and voice interaction. We are committing to helping you enjoy a new kind of lifestyle in your car, something you've never experienced before. And we are doing our best to make that a reality with many partners. So in-vehicle navigation systems has run on the embedded systems. So we have a restrict limits on the memories and CPU's uses. Even if we use the multi-core processor, the navigation system is typically limited to just one CPU core and have the available memory is usually less than 2 gigabytes. So even in these challenging conditions, we provide precise navigation by integrating HD maps and deep learning-based vision recognition for features like lane level guidance, indoor parking lot, and AR navigation. We are also developing realistic map using advanced graphics technology. Our high-definition maps and efficient software solutions are already being used in mass-produced vehicle. Plus, on top of everything I mentioned, all of our navigation features are available as a navigation SDK as well. So far, I will show you some of the latest technology in navigation systems. So now, the vehicle embedded systems are the vehicle embedded systems and the autonomous driving softwares are evolving quickly, right? But that makes us wonder, what should the next generation of navigation look like? Well, we believe that the future navigation should offer users dynamic content and game-like visuals, and also interactive elements. So that's the kind of experience we want to deliver to our users. To figure that out, so we decide to try using Unreal Engine in our navigation system. So that's how our journey began. We are a team of 4 developers with strong native OpenGL ES backgrounds, but absolutely no experience with Unreal Engine. So we started this project by teaching ourselves Unreal from scratch. We started last year, so we begin from the how to spawn the actors and how to make a blueprint like this. So we carry out this project in 3 stages. First, we designed an architecture that could display the vector data in real time within Unreal Engine. We also checked the feasibility of applying various effects in Unreal. And next, we focused on the key navigation elements, such as building, road, and point of interest, POI. And checked if we could display them as well as the current navigation systems, and also whether we could apply better effects to enhance the content. For these 1 and 2 pages, we just focused on the visual quality and did not consider the performance. Finally, in the last pages, we integrate the essential module like search and route guidance. So the user experience would like be our OEM navigation systems. We also optimize the performance and improve the rendering quality to ensure a smooth and high quality user experience. So let me show you how we got all this done. The first thing we had to figure out when starting this project was how to process map data in Unreal. So unlike typical games, the data we use isn't packaged as assets. Our maps are based on the vector tiles. Pretty much all the major map providers, like Google, Mapbox, or OpenStreetMap, use this format too. It all starts with a single label that covers the whole world. How far the cameras appears to be from the map determines the level of detail you see. So that we call the zoom level. As you zoom in, the entire world is divided into smaller chunks, and we call each of those chunks a tile. Each tile contains the map data in a vector data. It's not a mesh data. So as I mentioned earlier, instead of loading prepackaged assets, we download the vector data from online and load and parse processing and generate meshes in real time. We don't need to load all the tiles at once. So we only process the vector tiles that are currently inside the camera's view. To render vector tiles map in real time with Unreal, we design our system like this. First, the task of processing vector data is handled by the AutoEver map engine. We only handle the vector tiles that are inside the view system of the cameras in the map engine. Next, to render those in Unreal, we delivered the processed data to our UE plugin, which converts it into a U object meshes. Then the plugin creates the actors and components and place them in the Unreal world. You might be thinking, isn't it enough to just parse the data and process it and turn it into a mesh for rendering? But when it comes to displaying map data, there's actually another critical element to consider. It's the layer. Each tile does not just contain a single type of map data. Instead, it includes multiple features like background, vegetations, and waters, and roads, and buildings. So each of these features is described with geometry and metadata, so that we call layers. Just like you see on the screen, these layers of features are stacked up in order. So we actually drew the map using a paint algorithm. So we set up layer specifications that tell us the order to render each layer and how each one should look. So we needed a structure that we deliver a layer specification. For each scene, we had to know which tiles are included, and for each tile, what kind of hierarchy structure its layers had. So we built systems to pass along this information and we called it the AutoEver scene graph. Yes, it's the scene graph you know, but we redefined the node structure to fit the needs of the map visualization. We set up the scene graph so we can manage more than one scene at the same time. Because our map has multiple scenes showing at once. Each scene consists of several tiles, and each tile contains multiple layers, and each layer is made up of meshes. So for layers and the meshes netted with the tile, they are set up in a parent-child hierarchy, and each one uses a relative transform to their parent. Because the object within each layer use normalized coordinates, which are defined relative to the tile they belong to. On the other hand, on the right side of the screen, you will see what we call instant node. These are not tied on the specific tile, and they created in real time based on the live data or triggered by certain events. So typical example of instance nodes are things like a POI shown up as an overlay and current location symbol that update in real time. Okay, so now we've covered all the elements need to display a map, and let's take a back and look at the big pictures, our rendering pipeline that combines both map engines and Unreal Engine. First, the map engine processes the vector data for each scene and converts it into a mesh primitive, which are then handed over to our UE plugin. And next, our UE plugin generates this into a U object meshes and caches them into a mesh pool. For each scene, the tiles and layer information is passed to by the scene graph. Each node in the scene graph is mapped 1:1 to an actor in Unreal mode. For the lowest level mesh nodes, we attach the mesh components, but instead of creating new one every time, we fetch the pre-made UMesh component and from a mesh pool. And by reusing these cached meshes, we reduce the CPU load, and everything can run much faster. When a request comes in, we instantly return existing mesh from the pool instead of generating them from scratch. This approach ensures the objects like roads and buildings and landmarks can be rendered in sequence, allowing us to efficiently build up the full map scene. So let's take a look at what type we used in Unreal Engine to render each of the map contents. First, for the map's base layer, the background, we use off-screen rendering to express each background tile as a single texture. For each tile, features like grass and waters and roads are drawn in order based on their layers G order. We use Unreal Engine's Scene Capture 2D to create this render target texture. The reason we draw background tiles as a texture is so we can apply a height map. By using both the backgrounds and the background textures and height map, we are able to represent terrain elevation. So Unreal Engine doesn't natively support the multi-world, so everything is rendered in just one word. To work around this, we logically split the map into 2 words in the base level. The 4 objects that need to be rendered off screen, we set up a word that physically separated from the main word. So what you see in blue is the main word where the background is displayed. And you can see an example of the tile meshes with the background material applied. And the texture parameters for the background materials is setting use target texture. A render target textures is generated in another word. In the separate word, we place and render the objects that make up the background. Then using the Scene Capture 2D components, we capture the scene's view and create the 2D texture. Next, let's talk about how render the buildings. Buildings are one of the most important features for helping users understand their own locations and surrounding environments on the map. So there are actually 2 types of buildings on the map. So first, we have regular buildings, which are to create the various building polygon based on their footprint and height information. In Unreal, we use a procedural mesh for it. And second type is a landmark. We didn't use the pre-built static mesh assets for landmarks. Instead, we load the GLB files in real time and dynamically create a static mesh component using the GLTF runtime, which is the third-party plugin. And nature elements like trees and waters on the map is a crucial role in helping users understand their surrounding. The last lake or the park in particular acts a key landmark that makes it easier to maintain their sense of direction. For tiles, for trees, we place the instance static meshes based on the real-world coordinates of actual street trees. As for water, we create a dynamic water surface by animating a normal map to simulate realistic waves and ripples. This effect was applied in the background materials post-processing stage using both normal and specular properties. By combining realistic trees and the dynamic water animations, we are able to build a map that feels much closer to the real driving environment and helping drivers feel more connected to road. And the route line is implemented using spline component. As soon as you start your drive, the route line is created instantly as an object that isn't tied to any specific tile. For precision load elements like lane level, lanes and load marks and crosswalk, we use procedural mesh for it. While displaying these details with great accuracy, we can also provide true lane level guidance, including feature called carpet view that shows you exact which lane to follow. Lane level guidance help reduce the unnecessary lane changes and improve traffic flow and creating a smoother driving experience. POIs are on the key elements of the map. We can display them as an overlay using UMG, user motion graphics. And one of the great things about this is that we can easily edit widget properties right in the editor, like change the symbols or adjusting the text and the symbol alignment, and see the result instantly without having to rebuild. This was a huge advantage for us because it meant designers and developers could work together and immediately see the impact of their changes. So we make the whole development process much more efficient and faster. After displaying all the essential map contents, we set up multiple scenes. On the right side of the screen, unlikely the main maps, which focus on the ride guidance, this additional scenes was designed to give much more detailed view of surrounding vehicles and environment. So we set up a separate world physically placed away from the main world, and it's just for the details view. Since the main map and each additional maps are loaded and composed independently, so we can display different contents and styles in each scene. That means the main maps and the detail view can each have their own unique look and informations, and they can be shown at the same time without interfering with each other. And finally, we experienced with the various lighting effects on the map. We adjust the sun's position to reflect real world. Changes in lighting depends on the time of day. It allows to control shadows and brightness and color themes, and to create smooth transition from day to night, which really boosts a sense of realism. For the landmark, we use light map to achieve the building illumination effect. By doing this, we can make our landmark stand out and make the map more beautiful. When we first packaged the complete map, ran it on an Android device, we faced major challenges. Whenever we moved the map and new areas be loaded, we experienced severe frame drops. So to figure out what was causing this, so we used Onion Insights for profiling. So we cover that we are frequently spawn and response the new actor for our scene graph. Because we are constantly loading the new vector tiles and generating meshes in real time. To solve this, we focus on the optimizing how actors are spawned and registered. After making this improvement, we are able to reduce the frame time by about 50% on Android device. So how did we actually optimize this? The answer was object pooling. In typical PC game, where the resources are plentiful, so you might not need to worry about this kind of things. But in our case, we run on the embedded system, so we need to consider it. So because spawning actors can only be done on the game thread, so we could not just upload it to another thread for the better performance. So to get around this, we create a pool of actors and components ahead of time. Whenever we need to build a scene, we just reuse the one we've already made and just reset them after each use instead of always creating and destroy them. By increasing the reuse rate of the actors, we are able to significantly reduce the rows on the game thread. As a result, we doubled the frame rate and everything's run much more smoothly. So, okay, that's what we do. There's the result from our page 1. In page 1, we built the basic structures and tried out a variety of different features that Unreal Engine makes possible, like displaying a wide range of buildings and implementing time of day and light events. For the page 2, we focused on making the map feels even more realistic. So we added things like landmarks and day and night modes, and details like trees and water surface. All of this made the map much closer to what you'd expect from an actual navigation system. In page 3, we focus on improving the performance to achieve the faster response times. And we also applied the anti-aliasing for cleaners and higher quality visuals. And we added essential navigation features like search and route guidance. All of these enhancements help us drivers can smoother and more seamless navigation experience. We didn't just stop to displaying the map. We also explored the possibility of building AR navigations using Unreal and confirmed that it's definitely possible. Looking ahead, our goal is to integrate the navigation modules with a different level, and so everything can run together as a standalone applications. This will let us offer a variety of view modes and create an even richer navigation experience for our users. We have also some experimented with exciting possibility with PCG. For example, we could build entire buildings by combining building modules like windows and walls. So we didn't have to create a building polygons manually. And also, we confirmed that we can place the trees and other vegetations like grass in a natural way in selected areas. So even if there's no raw data for those areas. Moving forward, we plan to apply more of these features to create even more realistic and game-like visual fidelity in our maps. So there are a lot of things we really liked about using Unreal Engine for this project. First, it made us way more productive. Working together with designer in a single tool meant we could instantly share the results without having to rebuild the project every time. So this made collaboration much smoother and really sped things up. And also, Unreal's built-in rendering and lights solutions made it easy to achieve a high-level visual fidelity, letting us apply effects and represent objects right out of the box. So no need for extra builders or complicated shader setup. So this really lowered the technical barriers. And on other things, Unreal offers a great extensibility. So thanks to its well-established marketplace for plugins and assets, it was super easy to expand our project whenever we need to add new features and content. So for these reasons, we really believe that our project has unlimited potential with Unreal Engine. So going forward, we are planning to take things even further. So this video is our target made using Unreal. And this is the concept. For example, we are bringing in real-time traffic lights data and visualizing it right on the map. Actually, real-time traffic lights are already available in some areas in South Korea. And we also want to use the more of Unreal's feature like PCG to make our maps even more realistic and detailed. Plus, by using vision recognition, we are able to add dynamic contents like animations for nearby vehicles and pedestrians. So the maps feel much more alive. So our ultimate goal is to give drivers the most accurate information possible and to develop the navigation system that fit for both autonomous and next generation vehicle. If your company share our visions and you are interested in trying out our product or just want to know more, please reach out us at the emails below. We always open to new partners and collaborations and new ideas about what we can build together. And that's all for today. And before I finish up, I'd like to give a special thanks to Suyeon, Gite, and Usao, who worked with me this project, and as well as the entire graphics engine development team. Yeah. Thank you. Yeah, I'm pretty sure my teams are watching from the South Korea on YouTube right now. So, yeah. And I have a navigation device for the live demos for today. So if you are interested, let's meet at front of the session room, and I will show you the navigation system on device. Yeah, thank you all for coming and listening. Thank you so much.
All right, thank you so much for coming. I know it's kind of the end of the fest. It's been a great time. Thank you so much for taking the time to hear me talk about my experience in UEFN. I'm doing collabs, commissions, and creating, and how I've survived as Tom Jank here. Just a brief history of me for those who don't know. I originally started in the animation industry. I worked on many different things, from music video for AJR, from Netflix shows like Oni. I worked in my university, made a student Oscar-winning film, and I even got to work at Pixar making a crazy film called Elemental, where the main character was a light source. So really, at the end of the day, the Jank has always existed, but my real name is Austin Rodriguez. The name originally came from kind of just an anonymous name. I had a little bit of an anxiety when it came to posting on social media, and I needed some anonymity. Little did I know that in 2 years, I would be making projects for TMNT, for Clue, being able to make my own personal projects like Fortnite Football, and my soon-to-be released, hopefully by the end of the month, a Lego Pirates game. But to start off, to describe how UEFN is, I always use this term that it's kind of the Wild West. There is a lot of opportunity, a lot of unclaimed land, there's a lot of potential there. But there is the good, the bad, and the ugly. There can be, like in any ecosystem, like any new space, everything's still developing, whether it be the tools, or there could be bad actors, as well as just a lot of pain points when it comes to delayed roadmaps and features that you're really excited for. But for me, I'm just going to discuss a little bit about how I've survived with my survival guide. To note, the results may vary. My tips do not apply to everyone in every situation. This is just more of something to think about. Be like, okay, how can I apply this to me in my own situation? I don't have any kids. I'm married. It is very different for me and my experience here and the risk tolerances, but I'll discuss more about that later. The 3 arenas that I most work within is collaborating with other creators, doing commissions and contract work for bigger studios, as well as creating personal maps for me that I want to make that are just solo projects. But to start, I want to talk about collaborating with other creators. Working with a lot of the nerds in the room as well. I'm a nerd, and having a lot of fun doing it. For example, I'd like to just define what a collab, what I consider a collaboration is, and I'm working with other UEFN creators in the space, and we're splitting the engagement payout. For example, I worked and made Pizza Shop Tycoon with Slided Sloth and Trick Tiger that had a lot of success, and we were really happy with how it turned out. But as always, working with a team has its own kind of senses of risks. And just kind of discuss a little bit about what kind of the risks involved with there's uncertain payout. While you're working with this team and you're trying to make the best thing you can make, at the end of the day, you're still subservient to whether your marketing worked out, whether the discovery algorithm's working for you. And so it's not a for sure payment at the end of the day. It's high risk, high reward. And sometimes creators can be busy. I believe people in this room I have started projects with, and something happens, something gets distracted, a new thing gets announced, and the project itself kind of peters out. That is something that it happens to everybody, and it should never be taken personally, but know that that is something that can happen within a project. There's also a lot of trust required when you're working with another group or another person, because when you give them access to your project in UEFN, you're trusting them. They can see the source, they can look at your code, look at the assets, and so you really want to find people that you can trust. But along with risks, there are benefits. One of the best things about working in a team is that you can split up the work, that you don't have to do everything in a project. For me, I really like the programming side of things, and I know a lot of people who don't. And so working with people to split that up, they work in level design, I'm working on coding, is fantastic. As well as skill sharing. While I know more about coding, I can also show people what I've done, people can see what I've done, and you can discuss and learn so much just by hearing how other people think and how that can strengthen the whole. As well as builds community trust. There's an aspect of it when you work with a group of people, people notice, and they'll see, and they'll be like, oh, I like this guy, so if he's working with him, I I think I can trust him. And so that's one way to kind of get your name out there and get people to kind of know you and what kind of creator you are. I always recommend when you're working with this new team, you want to start small. You want to figure out a small scope project and release it. It's something little that can really tell you how you work together. Because sometimes, even if you're best of friends, sometimes a project you can kind of butt heads or you have a different perspective on what players like or what kind of map you want to make. And so working in this smaller scale thing can really help you both prepare and see what you expect. There's nothing worse when you're working on a project for a year with people that you weren't so sure about, and just kind of locked in because you feel bad. You want to leave a project like that. But always important when you start to start with a plan. Discuss. These are some example questions to think about when you're starting a project. What is the ultimate goal? How will you resolve artistic differences? Whose code will the project be released under? What is the punishment for not checking things back in if they've checked them out? Things like that can really kind of develop a relationship and really that rapport that you need as you go along. And when you plan these things at the beginning, you're setting expectations. You're able to prep and be ready for any kind of problems that may come. When you decided in the stressful time of development, it can kind of hurt that project quite a bit. A survival tip, I very much recommend getting a contract for the collab. I'm sure you two are the best of friends. You guys grew up together, everything's going perfect and great. I still would recommend getting a contract, talking to a lawyer, finding like a contract template. Things like that can really help just establish those expectations. Similar to creating a plan where it's like, okay, we're gonna be splitting 50-50 because there is a lot of money in this space that can, in a successful map popping off, it's good to have just those boundaries set up from the beginning. I also recommend picking a director for a project. This is something that I've found in a lot of my projects that when you have a lot of voices, a lot of people have really good ideas and great opinions and thinking that, oh, this should go there, this should go there. And you should listen to all of them. The collaboration is the best part of working with a group of people on an even playing field. However, when you have kind of one person, usually it's the person that had the main idea, they're kind of the last say. You want to pick someone that you can trust that will listen to everyone on the team, as well as the team trust that they will pick the idea that would be the best for it. And so I also like to establish kind of taking turns. When I work with Sloth and Trick Tiger, we talk about this at times because it's like for Pizza Shop Tycoon, that was kind of originally an idea that I brought to the group. And so I kind of was the lead on that. But the next project we want to have, Sloth is working as kind of the director of it. And kind of this last thing for this section is that no project is an island. What you do in every project defines yourself in the community. People talk. There are Discords, Twitter. We've all seen drama and the various things that happen in this ecosystem. And it's important to know and to act in kind of a professional way, but also an authentic way, to be honest and transparent with people. If you're having trouble on a project and you can't quite make time for it or other life shows up, just be honest with the people you work with and everyone will respect that. So the second section for commissions and contract work. This is something that I have worked in a lot in the past year. When I define commissions, I'm talking about working for a larger studio or brand to create a map or part of a map. There are also commissions that can do with smaller things. Random users will ask you for little things. In this talk, I'm just talking about these kind of larger projects with a big studio that they're kind of hiring you as a freelancer or consultant. One example is this awesome map that I was able to work on called Clue Murder Mystery with Look North World. Look North World has a much more, a larger group, bigger budgets, they have lawyers and things like that. And so they kind of worked with Hasbro and they asked me if I would help work on this map with them. And so it's something that's great because you're able to interface with this brand, but you don't have to have all the bells and whistles that's really needed when you have an agency and things like that. And so the idea that I was able to work on a clue map is crazy. If I told baby Jank that when I was little, he would have lost his mind. I played this all the time when I was a kid. So it's a fantastic thing we can do to create these projects in this ecosystem. But it's important to know the risks. you get a little bit less creative freedom. You are not the boss of this project. You are listening to a manager, a director, a lead. And so I have found at times that you kind of can get a sense of burnout a little bit when you got to do something that you don't quite love to do. That's something I kind of felt at Pixar a bit, where I would get these directions that I wasn't sure about, and it can be a little bit draining. There's also a question about engagement payout loss, the opportunity cost when it comes to the engagement. Generally with brands that I've worked with, it's different. It's important to know it's different in every situation, whether you talk to. But in general, I have found that usually it isn't really going to be a split engagement pay. Usually it's more of a flat fee. And that can be both a benefit as well as a lost opportunity. A lawyer may be required. Sometimes on the bigger contracts, it's good to have a lawyer review like who owns the things that you're making and things like that. And so it's good to kind of have that as a backup. However, there are a lot of benefits. For me, it's a bit of an energy saver. When you're working by yourself, you've got to plan everything, do everything. There is something kind of almost chill about just like, okay, I'm just gonna code the platform that's moving. I can focus on that, I can do that, and then all the rest of the team is kind of filling in the gaps. And so there's a bit of it's a bit of an energy saver in that way. There's financial security in it as well. There's a lot of stability when you know that you're getting this flat fee or you're getting this monthly salary. And that can be very nice in an ecosystem that can be very up and down. It also improves your resume. When you have a project that I could be like, I made Clue Murder Mystery with Hasbro, that looks really good and can really help you down the line to both in conversation starters, and other companies can see that and know that you can be trusted with a project like that. But when it comes down to it, there are kind of two battles when doing commissions. It's finding the actual commissions and then working the commissions. The first, finding the commissions, there are kind of 3 recommended steps that I give to people when they ask me, like, how am I finding the brand projects? How am I being seen? Show your skills on Twitter. Legitimately, kind of like I said in the State of Unreal talk, really my momentum built when I just started posting daily on Twitter. I posted these warm-ups. I would work on a little thing for an hour in the morning and post it. Posting consistently, posting as much as you can is very important. And it doesn't have to be in a warm-up format. That's what I found worked for me. I know people that have posted they've got a big project and they'll cut it up into little bits and then slowly show it as they go. But it's very important for the ecosystem and for these businesses to see that not only do you do work and you do it well, but you're also passionate about it. You do it outside of it. If you weren't doing anything, you're doing this. And so they really like to see that. Be professional. It is so important, your public perception online. Every post you do, everything you post is seen, and people will react. You can't control every way they'll react to it, but I really find it important to be to be authentic but also optimistic, and to understand that even in this bumpy roller coaster of this Wild West, that everyone is working hard. People at whether studios or at Epic Games, people are pushing and they're working, and it's a huge studio. Like I worked at Pixar, and watching how a giant studio, the struggles to move such a large boat, it can be there, and it's found in every project, no matter the scale. I always recommend to take a meeting, hear out an opportunity. Obviously not every meeting, but I've had so many meetings with projects that never actually got off the ground, but I was able to build a relationship with the group for future opportunities. Because sometimes you meet with like an agency and they're like, oh, we want to pitch something to this brand or things like that. It's good to talk to them and get to know them, and that can also build a relationship. Learn to say yes. Their money isn't the only profit that you can get out of a project. I'm not saying do the project on, oh, we'll pay you with exposure. That's not what I'm trying to say. What I'm saying is, kind of like before, opportunities can be built up. Sometimes it's a little less money than you're used to on your hourly or something like that, but sometimes that time you build skills, you can build so much when it comes to it. However, at the same time, learn to say no. There will always be another opportunity. This space is so chock full of opportunity, and it for me, I've always found that it kind of comes in waves. Like I'll get like 4 at once, and then 3 months won't have anything, but then I'll get 4 at once again. And so it's really important to balance your time and to watch out for your burnout and only accept things that you really feel comfortable choosing. I really think it's important not to compromise your brand or yourself, and that's something I'll talk a little bit more in Battle 2, in actually working commissions. You're not their secret weapon, and I'll talk a little bit more about that, but the first thing you do, just like in collaborations, is get in a call and discuss the following questions. Like, you need to plan out and find out what their expectations are. There are times where I've been in a project where I had no idea they wanted me to do like a 6-month thing afterwards, or things like that are so important. Like, what is going to be the once it's released, what's going to happen? Do I still own if I write code for them, do I own it? If I transfer my code from old projects to it, is that a problem? There are so many questions that you want to be able to get out there in front of everything, and not because there's such a stress when the release happens that it's tough to get nail down all these things when you're mid-project and you've already spent like 3 months on the project, you've been half paid. Things like that can become problematic. However, I think the most important thing to remember is they need you. There are not a ton of people in this ecosystem. We have such an advantage and such a chance, whether you do verse or you do level design and you're publishing. There's so many people that have been working in this space for 6 years, 4 years, 3 years, so many. But at the same time, those are very individual skills. Sometimes we just know bugs that might happen on publish that other people don't. And so I really, really want people to remember that you need to value yourself. They need you as much as you, I mean, they need you more than you need them, really, because as you know this ecosystem. And so in that kind of regard, I always recommend people when they're working is that you are not their employee. Like, you're not that secret weapon. Make it a collab. Be able to ask for them to put your logo next to it. Talk about when they're marketing it, please make sure to @ me and say that, hey, I also worked on this project. Look North World was awesome. I asked them at the beginning, it's like, I want my name to be part of it. This is Look North World with Tom Jank. And that has been huge for me. It's fighting for your brand and it's building for your brand. And so the safest bet is put in the contract itself, but it's always just good to make sure where the credit lies. Something I recommend when you're working with a director and a manager, and you're working in this kind of creative space as part of a team, it's something that I kind of learned over the time working for so many directors at Netflix and Pixar, is I call it the poke technique. You ask once and then you move on. There are times where I have a strong opinion on something. I'm like, this is gonna break so much stuff. That's when you ask once. You say, hey, this is gonna break stuff, you tell them, and then you move on if they decide to ignore it or whatever, because 3 months later when it does break, they'll be like, oh yeah, that guy said the right thing and you're on the record. But if you overdo it and you just are constantly harping on it over and over again, they don't want to work with you later, even if you were right. If you're like, I told you so, it's all about that professionalism, working with a director and a manager. But now to what I think is much more fun, creating your own maps. May the odds ever be in your favor. It is truly so satisfying to be able to work on your own projects. If you've got kind of the runway for it, or if you're able to do that, this is your vision. It's your map, your idea, your story. For me, one of my favorite maps that I've made is Fortnite Football. That kind of came up from a broken warm-up where I was picking up dinos and I kicked them across the room. And I was like, wait a second, it's kind of fun to kind of throw them around. And slowly but surely, it became a soccer game. And it was all custom physics. You don't even want to see the math, because that's the highest level of jank that I've probably ever coded. But I did all this math and stuff like that, and it was satisfying to release. And it did pretty well, luckily. However, there are risks when it comes to these personal projects. It's the riskiest financially. You are 100% up for it. The finances, even if it's 100% of the finances go to you, even if that's $0. The engagement power is the single financial source in these personal projects. Everything is your fault. You're completely responsible for every aspect of this map, from the marketing to the code. And for me, especially, there never seems to be enough time. There's so many ideas, so many new features, so many things, and so this is one of those times where you're really balancing whether it be your financial situation or just having ideas, just too many ideas to pick from. But there's so many benefits. That's high risk, high reward. If you succeed with a personal map, you receive all the engagement payout. That's something that can fund further personal projects going on, and it's exciting when it hits right. You definitely level up your skills. Building a map and publishing a map from scratch is extremely valuable in this ecosystem. While there are a lot of maps out there, there are not a lot of people that really know that from 0 to 100 how to do all those things, and that can be so valuable. The amount of times I've helped commissions been way easier because I published my own map, or I'm like, oh, I know that this thing's gonna break on join in progress. Okay, I need to be prepped for that. That saves so much hardship. And there's just a creative satisfaction. Making your own map and succeeding and building something is fantastic, and as I'm sure many of you know. But in the same way, there are two battles here: being a creator and making a map. In this space, a lot of people have different opinions on this. This is kind of my perspective on it. We are a creator in this space, a content creator. And a lot of times I try to explain to people, like my grandparents, what I do. And so this is usually the line that I try to kind of, it's like YouTube, but you know how people make videos and they make money watching videos? Well, I make games. No, I don't work for Fortnite. I don't have V-Bucks. No. But I can, it's always fun to explain. But when it comes down to it for me, it's branding. As you guys have probably noticed, my name is Tom Jank. I say it a lot. My first GDC, I said it like I was a Pokemon. I just want to get my name out there, and that is so important to be recognizable. I like brought this hat. My lovely wife, she made this hat for me, and I wear it, and people will come up to you and talk to you because they recognize the brand, or they like what you do and you talk, and I'm so honored to be recognized in this way. Like, seriously, I do not overlook the great privilege that I've had so far, and I really put it down to just me putting my logo in as many places as possible. So, always be branding, 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 always be branding. And so at the end of the day, marketing is also a skill. It's a game dev skill for us in this space. We are indie game dev people, and like I kind of said at the beginning, I was pretty anxious posting at the start of, I wasn't really sure what to post or how to post, or like I'd never even used Twitter before. But it was something that slowly built up as a muscle. I would post one day and I felt a little better, posted another day, posted. And so it just kind of builds. It was so weird one day that I was like, I like have this muscle that I just kind of know, oh, I know people will react well to this. And it's just something that comes with practice. And sometimes if you can't figure out whether it's like, hey, do I want to be posting warm-ups? Just start posting, see people's reaction. Didn't work, change it a little bit, always be kind of thinking about that. But the second battle is actually making the map. There's never enough time. You want to start with a plan. There are so many questions to ask. How long do you think it'll take? How long will the MVP take? Is there a hook that makes this a clickable game if I'm posting it on Twitter? Am I balancing, or how much do I want to balance mainstream, the things that are doing well on Discovery, or kind of my own innovations? Can I hire someone? Do I have any extra funding to hire someone to do some modeling that I don't want to do or don't know how to do? But I think always the most important question is, why this map? You have so many ideas. Answering this question for yourself will help you last through the entirety of the actual project. If your why this map is like, I don't know, you'll probably stop working on it when you hit that last 10% that is just so painful. But really hammering down why you want to make this map can really help you through that whole process. And I think truly, sometimes it just doesn't work out. Whether it be because of the gameplay is not quite working for the players, there's a bug, and sometimes it's seemingly for almost no reason. You're like, this should work, it should work. But it's kind of something that I have found has helped me get through projects not working out by accepting that at the beginning and just kind of having this expectation like, hey, this isn't the end of the world if it doesn't make it, but also sometimes you're just not going to get it right. Sometimes your game design, you got to learn a little bit more about game design. And that's something that helps me quite a lot. But kind of the last thing is what I believe is the superpower of a solo creator is the agility. This space is always changing. They announced Squid Game is coming out in, like a month or so. There's new projects, there's new tools, we've got Scene Graph. And your power as a solo creator is that you don't have so many dependents. You don't have a full team that you've got to kind of move to shift. And I really think that that's something that's really helped me, that I've been able to learn this agility. It's like, okay, I need to learn this tool real quick to do this thing, or I need to practice to do this thing. And so you can pivot and you're able to make these kind of adjustments based on whether it be the trends that are happening or kind of the projects that you want to work on. And so you having the control over this pivoting and agility can be so powerful. Yeah, and thank you so much for coming to our talk. That was Tom Jank's Survival Guide. And now we can open the floor for questions if anyone wants to ask.